So we'll continue our session. So we had left here. So I will cover some of the, I think you had done good, you have got good exposure to the RDD functions. Last time we covered most of it. Now we'll jump over to the data frame and dataset operations. So this sample I have taken from the Spark website only, Spark documentation. So we have, below, this is a JSON. And remember, the two names are same here. And these two names are same, age different. And this guy doesn't have the last name. Actually, none of this has a last name. This guy doesn't have the age. Right? So when I read the JSON, this is how you can read the JSON. So it will automatically print the, and you can say, you said spark.read.json and give the JSON file and then show it. So it will print all those things. Now, one important thing to notice is, for example, I have shown it, this is small JSON, for example, and all JSON, one record is one JSON. If the JSON is big and you want to split into two lines, one JSON split into two lines, then this won't work. So your JSON has to be in one line only. Each record is one complete JSON in itself. So then you can use spark.read.json and you can show it. So it will print the age for Michael was null and it will print everything. Now I want to say distinct. Now Justin, there were two Justin records which had the same age. So now you see when I say distinct, it's a data frame, by the way. You see this is a data frame. So when I say distinct, it will not, it will remove these two, one of these records, and it will print the rest of the records. And by the way, you see the schema, age and name and everything. Now I want to drop the duplicates. Now drop duplicates has, you can give one column or combination of columns. So if you saw the example here, so there were two names, two records with the same name. So when I say drop duplicates just with the name, it will drop the records which have the same name and give. See drop duplicates with name and age, two records with us which have same name and age. Here in case Justin had same name and age, so those will be dropped and rest will be given in the data frame, output data frame. So there are certain D operations. I've taken the same record, same data set which I have been giving, and this is a schema ID, name, date of birth, salary, designation, manager ID, address, and of course hobbies. I forgot to put comma hobbies here, but hobbies also. So I think most of you have seen the code. It might be just revision for you. So I created data frame out of it. So this is the code. So I import the necessary imports, create a schema, and then I say spark.read. And then give the schema. Then header equal to true. Then delimiter is equal to colon. And so this is what Anshul was saying. You could go dot option as many times, or you can give dot options in plural and pass a map inside. So either of these things will work. Now I've read the schema. So I want to invoke certain data frame functions or data set functions. So I have this imply. So I want to get the minimum salary. I can use say imply.aggregate and get the minimum salary. So homework for you is that you create a temp view to find the minimum salary from this data frame, from this data. I want to get the average salary, so I can get imply.aggregate and get the average salary. Now I want to add a new column. For example, people with salary greater than average are well paid, otherwise they are underpaid. So what I do is, so this average salary I have already created. So I say average salary dot collect. It will be only one record. So I can get 0 and I get that as a double. Then I say imply with column. So I'm adding a new column. So with column, it adds a new column to this data frame. I call that as a column as a pay bucket. So this is a powerful thing. You can use when condition also. So when column dot salary is less than 20,000, then it's underpaid. When column, okay, this is just hard coded. You could very well put this AS also. And when dot salary is greater than 20,000, you get well paid. If it is equal, basically, if it's not less than, if it's not greater than, then it will be equal. So you say dot otherwise and say enough paid. So idea here was to show you that you have these when conditions while creating the with column.
Is it different than if conditions?
So it's different than if. The if has case. So you use case conditions for if. This is when condition. So I think I might have some example of case also somewhere.
And one more question on the temp view. What is that actually?
We'll come to that. Sometimes I give a pointer to the things which I have not covered. So we'll come to temp view also.
Okay.
If I don't come to in this session, then there's a temp view, there's a global temp view. Go and read this yourself. Next session anyway, it will get covered.
Okay.
So we have in Dataframe.rdd functions. So it converts a data frame to RDD. And you use this when you have to use some operations which are only available in RDD. You can you want to save the data into parquet format and read it. So this is the example. This is the data I have in the data frame. So this data frame .write.parquet, give the location. Then you can say spark.read.parquet and read from the same location, and you can print it. So this is what this is how you save and read from parquet. This most of you have already covered. I will anyway cover it. So I am adding a new expression with salary, which is with tax, which is 90% in this case. So you have this data frame. So I created this data frame myself, and I given this schema salary and tax. And then so one way to do that would be that on this data frame, say with column, and give the column name, and you can have an expression. So what is my expression? My expression is this salary multiplied by some literal. So this salary has to be part of the schema, and it is because I have given this salary as part of the schema. Then I once I do that, then I print it and I say and then I just show it, and that's how it gets shown. Describe is a method in the a data set and data frame. It computes it's a function which computes statistics for the numeric column. So like in this example, I have given describe of salary. If I don't specify a column, I just say describe, then it will compute statistics for all the numeric columns in the data frame. This describe you should use only for exploratory analysis. What it shows is it shows the count, mean, standard deviation, mean, max. This is just if you want to explore. But if you really want the exact value of this, then you should use we have seen the aggregate mean, aggregate average, aggregate max, and there are ways to create the standard deviation and mean data frame. Use those. This is just for exploring. You want to get some idea what is the mean and what is the mean and what max. So that's why you use describe. There is for Hive tables, there is another function. I think we'll cover that when we go to the optimizer, cost-based optimizer. Hive has this explain table, not explain table, analyze, analyze table, give the table name, and compute statistics. It's one command: analyze table, table name, compute statistics. So that will compute information about Hive tables. So this is about the data frame.